let's continue from the last video. So we have built this Windows stopper module, and then but the question is one is this adjustment is 0, but it's interesting because if you put that in 0 here, you are not able to see what you are building this second cube. But I put that in 1, and later on we will see what's the these matter. So I don't go to this reading detail, but you can get some ideas what was this for the parameters going to build. Let's just continue. So we stop here like this Excel clearance. So here. Then we will have some wedge and lever. So we have our stopper modules parameter. So let's also give some window seeker. So first, this one is built for window. So let me see here. For window, and for window we have this tool, and then we will have for window stopper. So we have the until the Excel the clearance. Then we will have following parameter is for stopper. And we are starting to have 6 more. So wedge, start, radius. We will also put 0 as the default. Start, radius, and then wedge and radius. This will put 11. And wedge angle. This put 42. That is have the carefully calculated. And then we have 3 for lever. Lever depth. They gave 15. Lever length, they gave 40, and the lever angle gave 15 degree. Start angle of lever. Then we have those, and we will build this stopper. Stopper is first we have this Excel lens that will have the relationship with window thickness. It's bigger than this thickness, but how big is material? Thickness times 2 plus 2. So the reason is this Excel lens is just like what we have is y dimension for case size, and we add R2, so that is when we make that the center is 1 in left, 1 in right. So that is the this tool we will have to use, and then we build this our cylinder. Cylinder diameter is Excel diameter. Height is Excel length. What we have just calculated. Let's draw this. We got this cylinder on hand first, and then we will do the translate. First is well, what's this purpose? So let me see here. Go to parts is this one. So we will do some rotate, and then we will do the translate. So let's have a look for that. So first rotate minus 90, 0, 0. And give this tab. Yeah, close the parentheses. Then they come to like this way. And now we will do the translate. Translate to the stopper ways and the axle. So give this our tab. Where is that? It's here. So that is your stopper, because when you have a window and you put this stopper inside, and then this window will be fixed. So that is the first stopper, and what we will give our the parameter is the angle equal to 0. So where is the angle? Is we don't have that outside. It's when we call the stopper, angle is here. So where we use that? We haven't used this angle yet. Let's see how in the next one we will do that. So let me save and go to the 05. And then let's see what we have that. Axle height. We have this one. It's the window stopper. And the stopper, we already did this axle length calculation. And we have this cylinder here. Translate that to the middle. So that is just same as this rotate cylinder. So they are in the same direction, but one is the divided, the removed. One is the currently left. Axle height, and on Y is axle height divided by 2. Translate -1. Okay, so let's continue. So what we are build is we are starting to have this polygon, but we will make our the generative the for loop learning. So we want to have just a list or vector of the points. So here, if you write down preview, now we don't have this definition of points. So let's build this definition. Points should be our vector. So you can have this vector just like what we did before. It's give several points, then they will draw this 2D polygon. But for our purpose now is we will use this for loop, and we will make this kind of the vector. So that let me see here. If I want to make this highlight, we only see this first. Then let's do this for loop for I equal to 0 is by the degree. So per 5 degrees. So that is one circle. And we also learned this let. Let is to assign. Let is do the calculation. So let radius equal to wedge star r plus wedge and r minus wedge star r. So that will. So when they rotate, the radius is getting the increase. So increase how much is times I divided by 360 that is our actual radius. We are making the radius change. And then for this one is what we have is first x is the cosine I times the radius. Y is the sine I. So if we don't change our radius, you will get a circle. But we will do this change x and y. And then we have here, let's see, let arrow. So let's see what arrow. First syntax. Oh, syntax is let. Let radius equal to days plus days minus times days and here. So I should not have this semicolon first, then cosine, sine, this one and this one. And do we have these points? So let me echo points. We don't get these points out, so that means here we have some arrow. So you see here, I forgot about this close parentheses. Now I got our big list of this x, the radius, the points. So here, that perfect. Let's make these comments. So that is the way is you will always can have some the way to find out where is your the issues. So through this echo. And since I highlight our polygon, so I only see this polygon like here. But what this is our 2D. So what we need to do is well, we need to do the extruding. So let's do linear extrude height equal to wedge width. So let's first make that to 3D. So now just our thing is we just make that height. So which ways we have make this definition. So let's see where is the which ways. Which ways. Ignore unknown. So we haven't built this, but which base is here. So by default, it just gave you 100. So let's add this here. Which width is equal to window width divided minus 2. So actually it's like this. So window width, we have starting 10. I just gave our number, then window width is divided, remove 2, so it's 8. So now we have this linear extruding. And then let's rotate that. So what's this used for? So let's come to over here. So it's this part. So let's make this rotate and also do the translate. Now we have 3D, so you need to give x, y, z, 0, 0, wedge angle, and the plus angle. And the angle, now we gave 0. So now that is not impact. So we gave some rotate, then continue. We will further rotate, make that rotate to this angle. So rotate minus 90, 0, 0. Now we have this one. Let's see in our parts. It's actually this, but you remember is now our this cylinder is on the horizontal, so we stop that. But when we combine that, we can convert, rotate, then it will be coming to this direction. So the last transformation is we need to move to the same to this the cylinder. Cylinder we made this stop width half minus this length half and axial height. So the only difference is this one. So what we will do is we move to the target now. So let's see. So we move to here. And if we make this removed, then you can see we move to this stopper cylinder, and they are in the same the horizontal this center of the circle. So that is the number 5 we have done. Let's before we moving further, please read here. Since when you have a polygon, you can define a number of these the points in a vector or in a list. But what we have trying to do here is this keywords let. So we should have some radius that defined. This is the middle, the perimeter. We have the I as our step per 5 degree, but we need to have some radius as our another perimeter. So this radius is we gave this also relating to I. So that then we starting to use this radius, or you can put this replace the radius. So if I make let's make this Ctrl C, then make that comments. If I put some bigger part, let's see, I don't want this let, but I just wanted to have this to replace the radius, because the radius I just wanted to calculate directly. So those are the points we have calculated. Sine I, wedge. So this will be the, let me add this. We should have our parentheses. And this is a parentheses. You can see here, you get the same result. So that means it's using let. The big advantage is you can make your the actual the calculation easier. So let's see. So we use this way. Then you can keep in mind this what's the effect of this let can help you. So now what we have is same as this way. So we have our the stopper, and stopper is actually putting into here. But the interesting thing is looks like it's our this cylinder is length is not big enough. So axial length, let's see here, is the windows thick plus axial length windows thick plus 2 times material thickness. So material thickness, windows width, windows thickness. So if I say here window thickness is 20, but looks like it's these are not go to over here. So that is the interesting as let's do this troubleshooting. They should be coming to outside. All these are the translate is not enough. Let's see this translate. Stop width divided by 2. Translate height, angle, polygon, and this. Translate stopper width. Let's see how big of the stopper width. 30. 5, 7, 10, 0.5. All these are same. So stopper width, if I put that to 50, is this width is not change this part. So 30 is here. So what I just check is we are missing this one. So after we did on this stopper case, we should translate to the Y. So make that closer to this this stopper. So that is the thing we are not having. So now you see here, we make this window stopper or stopper case go to this -1. Then they are putting together. So here is 1, here is another 1. So that is what we have this +2 the effect. So let's back to our part is this one, and when they stop, they will put into this case, and we only have this one need to build further. So that is the part is we are moving to here. So we have finished this sub-module stopper case, and we are doing this stopper, and we have these points put in here, and we analyze this one, and what we will going to do is this one we don't have that, but here is introduce some way of your look. You can open the different angle. So you can use your mouse to rotate, but if you just want to back to a standard angle, this one is from the top, and this one from the bottom. From the another, this you see here X is in the middle. That means you look at from the positive X. This is from the negative X. So let's continue on this one. So this is almost the last one we will do to make the stopper the calculate. So we let's save this. Smaller. Then save. Save as 206. So what we will do is on this mode stopper, we will put this stopper aside. So here there is Excel height. We have that still. So Excel height, no change. But on this stopper, we start to have this, and we have the translate of this cylinder. So that's no change. We define the points and make our wedge width and do this polygon. And after that is we should now have our the circle, and make that how. So that is the one new thing is we can try to study. So let me put here. So let's make the highlight, we only focus on what we are doing now. So circle D equal to Excel EM. So let's do this one by one. So what we are having, so we have this circle, and we have another circle. D equal to Excel DM times 0.66, and we will make the translate to our length. We translate to X degree. But what we will do is we make that how. So let's first we have making them, putting together. This how. So you see here. So that means is you have first this one and this one. See? So if I make F6, you see the both. But if you put this F5, we can see the inside. I put this two circle as the transparent. So now you see we draw these two, and the whole is just make this transformation similar to Boolean, like operate on the geometry, translate, generate the joint convex hole over these two parts. So this make this transformation smooth. So let's make hole here. And what we will further do is we will make the linear extrude. Height is the lever depth. You see, we have this one. And what's this used for? This is here. So then we need to rotate, because now is our cylinder is on the horizontal. We need to rotate, move. So just some more transformation. So first is rotate like the other two parts. It's 90, 0, 0. So we got this come to this direction. And then we need to rotate to some precise angle. 0, lever angle, plus angle. Now angle is 0, so we will need to adjust that later on. So now we have this. Let me see. Oh, this is close appearances. Now getting these ones. Now we will translate that. Translate to same one as another two parts did. So you translate to here. And if I remove this, you see you translate exactly to the same Excel of this another two parts. So that's almost done for our parts now. So it's already in this good shape. And what we are going to do is we can starting to call some the modules with predefined the perimeter. Let's save this to 7, and with 7 we can start to use that. Inside here we have a window and the Windows case, but here as a stopper we move that to some distance away. So we are starting to give stopper is only the angle. So angle impact these three parts. So if I say 45, now you can see you can starting to control this moving, but we don't have those. Normally, is your Windows move here is the bottom, so you don't have a way to move to this range. But if you have that 100, then you make that open. So then Windows can go outside, and if you make that 0, then you make that stopped. So that is the working for this module. And here is also the print version. So if we see if you want to print, you'd better to make this separate. Otherwise, they will print as one joint, the shape. And by the way, so now you can make this is bigger. So let's make that in the 50. So now it looks smoother. And if I have a print version, then I will go to some more rotate. If not print version, then it's just joint. So that is the part is let's make our number 8, the last one. So we are putting the conditional, the calling is to this how you call this this parameter. So Windows stopper. So let's see. So we add one more. So printing option. So print version equal to false. So by default is not the print. So then what we will going to do is we will add here. So if print version. So that means if that true, so we will have something, and then the else we will have our parts is like this. So that is the else we will do. So let's run this. So no change, and you can still manage this. So because here is the empty, so let's add this true. So if that's true, so we should draw our stop case. So let me see. So I put that outside. Print version equal to true. So I only draw this case now, and I need the other case part is translate. So window, and we don't need to draw window. So just this stop translate, and with this rotate. So we only need to draw a stopper. So stopper. So stopper by default is here. Let's do translate. So first we do translate first, and we can see here this is our stopper. We make that translate to here, and we can make that the convert and make this into the bottom. So that is the discussed that we have done before is to ensure your 3D printer you know how to control this orientation. So 90 0 0. So you see here. So that is exactly same as what this sample program is doing. So let me save on this. That is the last model, and you can download this complete file to generate this directly. So on the printed one, we don't need to show the window, but if that is the false, you see here, this is the window. And then we can see we gave some window thickness, window distance. Let's see. Window thickness is 10, and the window, this one, this is not change. Window. So this, if I put that 20, that is the larger window. So you can see, so 10 is this one, and also we have our window here. So Q is just 0.1. So if I say here, the actual window should be the 100. So you get this, you have an idea is when you control this stopper, you are putting the window inside, and now the window is stopped. So that's the actual the purpose for your modeling here. But when you do this, the printer version, you don't need to print the window definitely. So that's the case. So we will finish this video. Thank you for watching. And next video we will go to this clock movement. So that is we are starting to learn some animation. Bye for now.